We're going to review a lot of things you already know about mathematics in preparation for what we're going to do today. And today is very, very simple, but you need to understand how all of this works or you're going to forget it in a hurry and it won't be very useful to you. So let's look at one of the rules of multiplication and division, or multiplication and addition. If I had this, what I have here is a multiplication problem, and then on one side there's a binomial. So it's kind of a monomial times a binomial. And I can distribute this and get 4x plus 12. Those are exactly the same, but I have combined them using multiplication, right? And I can't do anything else because there are no like terms, okay? And actually, this little trick with multiplication and addition is how our whole number system is based. Anyway, it's beyond you. Don't worry about it. But I can also go backwards. If I had 15x squared minus 10x, this has been combined. Can I expand it back to its original form? I can pull out a 5x. So 5x times x minus, or wait, 3x minus 2. Those are exactly the same. Sometimes it's advantageous to distribute that coefficient. It will give you an advantage. Yeah, advantageous. Yeah, got it. Sometimes multiplying that through makes sense. Sometimes you need to do that. Other times, factoring out that common factor makes sense. It just depends on what you're doing and how it's set up, and sometimes you do one and sometimes you do the other. Just whatever happens. But the important thing is you need to know how to go from here to here. You also need to know how to go from here to here. We're going to do something similar with logarithms. We're just going to convert from one version to another and then back. Okay? There are 3 rules governing logarithms. We're going to look at those rules in exponential form, and then we'll look at them in logarithm form, and then we'll get to your worksheet. Okay, so you don't need to write anything down, you just watch this. So if I had x to the third times x squared, can I combine those? Yes. Why am I allowed to combine them? The same base, right? So this is the same as x to the 5th, which is x to the 3 plus 2. Everybody gets that, right? Well, what if I had x to the 3rd times y squared? I can't combine them because the bases are different. Okay? And I don't know what the bases are, but anyway. So that's not possible. So really, this x to the 5th could be a huge number of different possibilities. I could make it x to the 4th times x to the 1st. That's the same thing, right? I could switch it around and do a 2 here and a 3 here. It doesn't matter. This is called the product rule. The product rule shows up all over in mathematics. This is the first time you're going to see it. But it basically says if the bases are the same, if you're multiplying, you can convert it using addition. So this connection between multiplication and addition. There's a product rule in calculus. There's a product rule in linear algebra. There's another product rule in calculus. So something like this is really common. You take a multiplication and you expand it using addition, which is something we've done over and over and over. We just never called it the product rule. So 4 plus 4 plus 4 can be rewritten as 3 times 4. And this relationship between addition and multiplication is how all of our numerical mathematics is based. The fact that this works allows us to do everything else we do. Okay. Likewise, there's something called the quotient rule. The quotient rule says if I had x to the third and I divide it by x squared, that's the same as x to the first, and we accomplish that by doing x to the third minus 2. Right? This is called the quotient rule. And we're going to adapt that into logarithms in just a second. But you've forgotten everything you used to know about logarithms. So, what does this button on your calculator mean? Log base 10. Good. What does this button on your calculator mean? It's natural log, of course. ln, natural log. Yeah. Log base e. Do you remember what e is? No. E is 2.71. It's irrational like pi, goes on forever, never repeats. E is a very common base for exponents because things in the natural world, they compound continuously. So remember last year when we did all that stuff with money, and if you compounded once a year, you didn't make as much money as you compounded twice a year, and it's more if you did 4 times a year. And we eventually compounded every instant of every second. We compounded an infinite number of times, and if you do that, then your base becomes e. And there are lots of other uses for e. Well, that's okay. You forget everything I say anyway. Once again, you're not in here because you're going to use this later on, but you will use your problem-solving skills. At least that's what I tell myself, or else I can't get out of bed in the morning. Okay. So. Oh boy, I walked right into that one, didn't I? Okay, so let's say we had $15 and we were increasing it 20% for an unknown number of years, and I wanted to know how long is it going to take before I get to $300. Now, a 20% interest would be amazing. So, if somebody tells you they'll give you 20% interest, it's probably a scam, and they're just going to run off with your money. So, to solve this, we would divide by 15. So I get 1.2 to the x equals 20. And here's the problem we ran into. We didn't know how to get the x out of the exponent, but we've now come up with 2 ways to do it. One is just convert straight to logs. So what would this be written in logarithm form? Log base 1.2 of 20 equals x. That's one way. Okay? The other way is to use what we call the power rule. The power rule allows us to drop exponents in front of logarithms. So what we do is we take the ln, or the log, of either side. We drop this x down, and I now have x times ln of 1.2 equals the ln of 20. And I've turned an exponential equation into a multiplication problem. And now all I have to do is divide by ln of 1.2. Well, so I natural log both sides. That allows me to drop the x. That's called the power rule. If you have a number in front of a log, you can turn it into an exponent. If you have an exponent, you can drop it down. Okay? So now it's just x times ln. So I just divide the ln off, and that goes away. And here, I don't have this button on my calculator. I don't have log base 1.2. So before the break, we learned the change of base rule, which says you can change this to either that button or this button by doing the ln of that divided by the ln of this. So you could either do log 20 over log 1.2, or you could do ln 20 over ln 1.2, which is exactly what we got over there. So there are 2 ways to do it. You can either take the exponential equation, convert it into this, and then change the base. Or you can ln both sides, drop the x, divide over, and it's already converted. So if we look at that, ln 20 divided by the ln of 1.2, this should tell me how many years it would take. It takes 16.4 years. So if I did the same thing with the log button, it's going to give me the same answer. Oops. So really, they gave us 2 buttons on our calculator, and we only needed 1. If you know 1 logarithm, you can figure out all the others by just changing the base. Okay? Oh, and by the way, if you have one of the newer versions of the calculator, and I never bothered to do this because it takes more time, you can push math and then go up from the bottom, and it will actually let you type them in. But I don't ever do this because it takes more time to find it than just do ln 20 divide ln 1.2. Yeah. Yes. Yes. And the potato's name is Rondi, apparently. Don't ask. I don't know. She doesn't know. Nobody knows. Okay. So, no, she did it, but the reason it's a potato, we don't know. We don't know why. Okay. So now we're going to apply the product rule to logarithms. So if I had x to the third times x squared equaled some unknown number, okay, I can convert that to x to the fifth equals some unknown number. Let's put that in logarithm form and see what happens. Log base x of some number is 5, right? Well, what if I split the 5 into this? What would the 5 look like if I were to split it in the top one? 3 plus 2. So if this side was 3 plus 2, then what would go where that question mark is? What 2 numbers do you multiply together to get x to the fifth? This one and this one. X to the third times x squared. So, so this would actually be x to the fifth, right? I mean, we knew that. So what this is saying is, if you take something inside a logarithm and you split it into 2 multiplications, then the exponents are going to split according to addition. Does that make sense? So if this gets split into a multiplication problem, if I turn x to the fifth into x to the third times x squared, okay, then this gets split according to addition. Okay, maybe if I use numbers it would make more sense. So let's say 2 to the 7th is 128. So log base 2 of 128 equals 7. What's a big number that goes into 128? How about 32? What is 128 divided by 32? So log base 2, if I split this into 4 times 32, I haven't changed the problem. What's the result on this side? How does the 7 split? 2 plus 5. Because this is 2 to the second power is 4, and 2 to the fifth power is 32. Okay? So if you turn this into a product, if you multiply, then this turns into a sum. It's the equivalent of distributing. Sometimes distributing makes sense, and sometimes factoring makes sense. You'll see it in a second. So this right here can be written as a logarithm, and I hope this doesn't confuse you, and if it does, I know Nathan's already mad at me, but okay. So this is actually log base 2 of 4 times 32 is equivalent to log base 2 of 4 plus log base 2 of 5, nope, of 32, sorry. And that's what we're saying. If I did log base 2 of 128, it takes 7 2's to do that. But if I split the 128 into a 4 and a 32, 2 of those 2's are here, right? 2 to what power is 4? 2. And then 2 to what power is 32? 5. But the important thing is, on this side, it's 2 plus 5. And on this side, it's 4 times 32. Yes. I'll show you in a second. Okay. Well, likewise, we can do the quotient rule. So let me show you, I'll show you the product rule and the quotient rule. Okay, so here is the quotient rule, or the product rule. Product rule says, if you have log base A of a product, you can split that into 2 separate positive logarithms. So we did 4, 32 with a 2 there, 2, 4, and 2, 32. Right? If this is a product, I can split them into 2 additions. Well, likewise, if you have a quotient, you can split it into 1 positive and 1 negative. Okay? The numerator becomes positive and the denominator becomes negative. Now, if I look like I've made this really confusing, watch how easy it is. Let's say I had log base A of 5xy over zw. There are 3 numbers in the numerator. They will all get positive logarithms. There are 2 numbers in the denominator. They all get negative logarithms. So we're going to split this into 5 logs, and they'll all be base A. Log base A of 5 plus log base A of x plus log base A of y minus log base A of z minus log base A of w. So this gets a positive here. This gets a positive. This gets a positive. This gets a negative. And this gets a negative. That's all we've done. Can you hang on just another second? Yes. Okay. So, oops, wrong button. Look at number 1. So here would I use the product or the quotient rule? Product rule. So the product rule would be log base 3 and log base 3. One of them gets a 2 and one of them gets an x. What is the sign on the first logarithm? Positive. Second logarithm? Positive. Now if you look here, we have separated the 2 from the x. And that's one reason you might want to do it. There are lots of reasons. Well, if you were solving for x, you can split the 2 and the x this way. And it's really similar to back in junior high, you were taught how to put this 4 in. Okay? And then last year, we taught you how to take that 4 out. And then there are lots of reasons why you might need to do one or might need to do the other. Today, all we're practicing is combining and expanding. Combining and expanding. And then tomorrow, well, not tomorrow, but it would be Wednesday, will teach you more about why you need to do one or do the other. Okay? Okay, number 2. Yeah, we're just practicing putting them together and taking them apart. So number 2, I can use the product rule, and there are going to be 3 logarithms. What are the signs of those? They're all positive. Right. So log base 2 of C plus log base 2 of D plus log base 2 of E. Okay? So we're just practicing the product rule. Hang on. Don't get ahead of me. Okay, 3. Product or quotient rule? Quotient rule. So ln, what's the base on ln? E. And that's it. So yeah, it's dividing. So anything in the numerator gets a positive. Anything in the denominator gets a negative. Okay, number 4. Product or quotient? Both. So it's log base 10, which means I don't need to write the 10. So log 3, log x, and log y. What are the signs? Positive, positive, negative. Does everybody get that? Okay. And so you can remember, if you multiply x's together, you add the exponents. If you divide x's, you subtract exponents. If I had x to the 5th over x to the 3rd, that's x squared, which is, I got it by doing this. So multiplication and addition are linked, and division and subtraction are linked. And if you continue on in math, you're going to see that pattern over and over and over. Okay. Number 5 is a little tricky. How many logs am I going to split this into? So let's not distribute, but I will in a second because I want to show you something. So if I look at factors and division, how many actually multiplications and divisions are taking place? So I have a 4, I have an x plus y, and I have a 5. So that means there are 3 logarithms. Log base 7 of 4. That's why we did this one. Log base 7 of 5. So this is one number. It's considered one number. And it's not multiplication. So this 4 is in the numerator, it's positive. This is in the numerator, it's also positive. And this one's in the denominator, so it's negative. But if you look up at the rules, nowhere does it allow to split a sum. Okay, and that's a really common mistake. People say, oh, this is log base 7 of x plus log base 7 of y, and that's not true. If you multiply on the inside, then your exponents add together. But if you add on the inside, there's nothing you can do. So what if we went back and we distributed? So log base 7 of 4x plus 4y over 5. How many logs would I split that into? Just 2. There's one term on top and one term on bottom. This would all be treated as one number. Not necessarily. If it was x's and y's, you'd probably want to do it the other way. It just depends on what you're doing. Yeah, we're just learning how to swing the hammer. We're not going to be solving any problems today. We're just practicing going back and forth. And we'll get to solving another day. Okay, what about number 6? Is there a rule that says we can change the log of one number times the log of another number? No. There's nothing we can do to this. But the bases are the same. Doesn't matter. There's nothing, we can't combine it. There's just nothing we can do. Okay. Yep, nothing we can do. All right, number 7. Now we're going to go backwards. When we use the product rule in reverse, first we have to make sure that the bases are the same, and then we put positive logarithms on top and negative logarithms on the bottom. So number 7 would be log base 4 of GH, and you probably want to put parentheses around that. Okay. That's it. So number 8, they're both W's. So log base W of 3/4. That would be it. Now number 9 is kind of tricky because we're combining 1 log base 10 of 3 and 2 log base 10s of x's. So I need to apply the power rule before I apply the product and quotient rules. Meaning, this 2 in front causes some problems. But I can move that 2 up here and get rid of it there. No, it's not log base 10 of 3 plus 2. It was log base 10 of 3 plus 2 versions of log base 10 of x. So if those parentheses aren't there, then you only take the first number. Yeah. So this 3 comes up here, and since it's base 10, I don't need to write it. So log of 3x squared over y to the third, and you see now why you need those parentheses. If they're not listed, then that second number does not belong to the logarithm. Okay, does that make sense? Okay, number 10. What do we do with 10? Nothing. The bases are not the same, so we cannot combine the exponents. Okay? Then number 11, I'm just going to do this all in one step. ln, what goes on top? 2 times x minus 4 cubed over y squared. Does that make sense? Okay. And then number 12, they're all base d. So log base d of a to the 4th b squared over a to the 3rd c squared. But if I look at that, can I simplify? What simplifies? So I could turn it into log base d of ab squared over c squared. And then if it simplified, I probably could have noticed that before I got started. Do you see any like terms in the original statement? This logarithm and that logarithm match. I could just do 4 minus 3, which would be 1 log base d of, what would it be, a? Does this show up down here? Yeah, it's right there. So all of this is kind of interconnected. Hopefully you see how that works a little bit. So on the back side, all you're doing is converting from one version to the other. But if you look at number 21, can 21, wait, not 24, 21. Can 21 be turned into multiple logarithms? Not in its current state. But if I factored it into 2 separate parentheses, then I could split it using the product rule. Okay? So, no solving, you're just converting from one version to the other, depending on whatever the instructions say. All right? Good luck.